This is for Year 11 methods that comes out of 16D question 6, where we're using a range of appropriate methods to estimate the instantaneous rate of change. Okay, I know that I've got y equals the square root of 16 minus x squared. Now that is a semicircle. If I was to square both sides, I get y squared equals 16 minus x squared, which means x squared plus y squared equals 4 squared. So it's a circle centered at 0, 0 with a radius of 4, but I only have the positive square root. So it looks like this, going from 4 to negative 4, thus the restricted domain. Okay, in part A, it says estimate the instantaneous rate of change at x equals 0. And I can see that's the top of the circle, therefore a tangent will be y equals 4, therefore the instantaneous rate of change at that particular point is going to be equal to 0. At x equals 3, I'm going to use the attach a tangent, and I've drawn a tangent here, and I've attached it at 3. So I need to estimate. So I might pick this point, because that point I can see is to be 4 and 1.5. And I might estimate this point here, which is 0 and 6. I've chosen those 2 points because I could easily read from the axis the particular values. Therefore the gradient is going to be y2, which is 1.5 minus 6 over 4 minus 0, or negative 4.5 on 4, which is negative 1.125. So that's my estimate for the instantaneous rate of change at x equals 3. That's going to be negative 1.125. Okay, and lastly, I'd like to estimate what the instantaneous rate of change is when x equals 2. And the way I'm going to do that is I'm going to use the chord that goes from x equals 0 to x equals 2, then x equals 1 to x equals 2, then x equals 1.9 to x equals 2, to x equals 1.99 to x equals 2. And I'm going to look at those gradients, and as they move closer and closer and closer to x equals 2, I should be able to estimate the rate of change at that point. So what I might do is, okay, I'm going to do this using my calculator. So I'm going to, I've got 16 minus x squared, so I'm going to define it. Now, each of these, for instance, this one, will be f of 2 minus f of 0 minus f of 2 over 0 minus 2. Then the next one will be f of 1 minus f of 2 over 0 minus, so 1 minus 2. So I'd like a rule which is f of x minus f of 2 over x minus 2, because x in the first case was 0, x in the second case was 1, x in the third case will be 1.9, then 1.99. So I take this and I'm going to go, bring up my keyboard, math 3 given, x equals 0. And press XE, and I get that as being the estimated instantaneous rate of change using the line from 0 to 2. If I go to 1, it's negative 0.4. If I go to 1.9, it's negative 0.558. If I go to 1.99, 575. If I go to 1.9999999, 0.57735. If I go 9999 and put some more nines, that is, I'm taking my second point so close to the first point, it's almost on top of each other, and I get undefined. So maybe get rid of some of them. Didn't like so many nines, couldn't calculate it. It's so close, it's going to give me 0. Okay, so I'm thinking that I'm approaching, for x equals 2, the instantaneous rate of change of negative 0.57735 by looking at what happened as I got a chord further away. I was negative 2.7, then I got negative 0.41, negative 0.558, and then we honed in on negative 0.57735. So this method is a method of estimating instantaneous rate of change given chords, where I take the chord from so diagrammatically I was estimating here at 2. So I draw a chord from 0 to 2, then 1 to 2, then 1.9 to 2, 1.99999 to 2, and I work out the gradient of the chord. The trick is I start a long way away, then I get closer and closer and closer, and I use my numbers. Now obviously, because I had a square root, a very difficult question not to do with it without your calculator.